Log equations. Before I go through some examples, some things that are going to help you immensely. The log base b of a is equal to the log base b of x, whatever. Same base, the arguments are equal. We don't cross off the logs. There's a property that says if the bases are the same, therefore the arguments are the same. Another little identity, I guess you could call it, the log base b to the x of a. You have some base to a power of an argument. This is 1 over x times the log base b of a. The exponent comes out, you take the reciprocal. This is going to be supremely helpful as we're going through some solving problems. Okay, first, let's look at the log base 4 of x squared minus 9. I'm not even going to finish writing down the problem. As soon as you see x squared minus 9, you should be thinking right away, difference of two squares, x plus 3, x minus 3. Recognize those patterns. Subtract logs, divide arguments, and I'm going to go ahead and factor x squared minus 9. This is the log base 4 of x plus 3, x minus 3, pattern x squared minus 9. Subtract logs, divide arguments. You do not divide logs. The only time you divide logs is with change of base. Reduce, we do not cancel. Reduce, we get the log base 4 of x minus 3 equals 3. It's in log form. Change it to exponential form. 4 cubed is 64, plus 3 is 67. Always go back and check. Always go back and check. The number one thing you need to be careful about is your argument greater than 0? I'm not going to square 67, but I know that when I square 67 and I subtract 9, that's more than 0. And I know that 67 plus 3 is greater than 0. So at least I know for sure that 67 is within the domain. The next one is going to involve the property that I gave you at the beginning of the video. So I have the log base 9 of x plus 3 times the log base 3 of x equals 14. They're not the same base, but I can make them the same base. The log base 9 of x is the log base 3 squared of x. The 2 comes out as 1/2. So I now have 1/2 times the log base 3 of x. The exponent, take it out as a reciprocal, which is 1/2. This is great. I have base 3. I have base 3. So this is going to become log base 3 of x cubed. And I'm just going to rewrite that. Okay, I'm going to bring the 1/2 up. I'm going to bring the 1/2 up using the power property. And then when I add logs, I multiply the arguments. So this becomes the log base 3 of x to the 1/2, which is actually the square root of x, plus the log base 3 of x cubed is 14. Okay, add logs, multiply arguments. So in the previous example, subtract logs, divide arguments, and now I add logs and I multiply arguments. So this becomes the log base 3 of x to the 1/2 times x cubed. And if you're doing the problem on your own, you're probably thinking, oh, this can't be right, but it is. So x to the 1/2 times x cubed is add exponents. That's 3.5, and 3.5 is what, 7/2, I think. Okay. If you wanted to, you could bring the 7/2 down in front and then divide both sides by 7/2. That's totally an option. I decided just to change forms. So I'll do this both ways. I changed forms and I said 3 to the 14th is x to the 7/2. Really, Miss Babiak? 3 to the 14th? That's huge, but it's not really. I mean, yes, it's huge, but it doesn't really, it's not an issue. Raised to the reciprocal power. The reciprocal power of 7/2 is 2/7. The reciprocal power is 2/7. Wait. Why did I do that? Because power property, there are a lot of properties involved in this particular question. Power property, when you multiply, you get 14 over 14, which is 1. So you end up with x to the 1st. That's not so bad. Wow, 14 times 2/7, that's not so bad either. That's just 4. So you get x equals 81. If you chose to bring down the 7/2, I'm just going to rewrite it. Instead of changing forms, if you said, okay, let's bring the 7/2 in front using the power property, divide both sides by 7/2. I don't like that. I'm going to multiply by the reciprocal. So divide by 7/2 is gross. So instead, multiply both sides by 2/7. So this gives you the log base 3 of x. 14 times 2/7 is 4. And now you change forms. You get 81 either way. Which way is better makes no difference. Both of them follow proper mathematical rules. So it doesn't matter which way you do that. Okay, let's look at another property, or problem that involves another property. Let's look at the log base 2 of x to the log base 2 of x. This looks fancy schmancy. Okay. Well, I was hoping when I first wrote this problem down, I was thinking, oh, if this base is an x, that would be really nice, but it's not. What I'm going to do is use the power property, and I'm going to use the power property. This is going, so bring this down in front. So this is going to become the log base 2 of x times the log base 2 of x equals 4. So I brought the exponent down and it just happens to be the same as the base. So the log base 2 of x is an exponent, as well as the log base 2 of x is a base. So this really is the same thing as the log base 2 of x quantity squared. Right? When you multiply something by itself, sorry, this 2 is the exponent. That 2 right there is part of the base of the line above. Sorry, it's kind of confusing. All right, well, how do I solve this? I'm going to square root both sides. So when you square root both sides, the square root of the log base 2 of x quantity squared is the log base 2 of x. When you square root 4, be careful, it's plus or minus 2. So I'm going to separate this. This is the log base 2 of x equals 2, or the log base 2 of x, equal sign, equals -2. Square root of 4 is plus or minus 2. When you're solving, 2 answers. So 2 squared is 4. 2 to the -2 is 1/4. I skipped the step. 2 to the negative 2 is 1/4. So side note, if you have x squared equals 4, 2 answers. The degree is 2. X is plus or minus 2. That's why it's both. 2 answers. 2 squared, 4. Quantity negative 2 squared, also 4. I'm going to do one more. I pulled out my erasable pen because if I make a mistake, it's going to be icky. All right. Log base 2 of x plus log base 6 of x equals 3. I don't like this problem already. They don't have the same base, so I can't multiply the arguments. I can't do one of those fancy properties. I can't write 6 with a base of 2. So, well, change of base, common denominator. Here we go. The log base 2 of x using change of base is the log of x over the log of 2. The log base 6 of x using change of base is the log of x over the log of 6. Add fractions, you need a common denominator. So the common denominator between the log of 2 and the log of 6 is the log of 2 times the log of 6. The first fraction becomes the log of x times the log of 6. Second fraction becomes the log of 2 times the log of x, and that's going to equal 3. Okay, so keep in mind, the goal is to solve for x. The goal is to solve for x. The log of x times the log of 6 is not the log of 6x. The log of 2 times the log of x is not the log of 2x. All right, well, let's write this as one big fraction. So that is the log of x, log of 6, plus the log of 2, log of x, all over the log of 2 times the log of 6. Okay, I'm going to multiply both sides by the log of 2 times the log of 6, which again is not the log of 12. That is not the log of 12. So this is the log of x times the log of 6 plus the log of 2 times the log of x, and that's going to equal to 3 times the log of 2 times the log of 6. You'd like to look at that as cross multiplying. I multiplied both sides to get rid of the fraction on the left. All right, remember the goal is to solve for x. Well, they have a log of x in common on the left-hand side. Each term has a log of x, so I'm going to factor that out. By the way, those of you who like to skip steps in the homework and all you do is turn in, like one step, that ain't going to cut it. No way. This is now the log of 6 plus the log of 2. This is the log of 12. Log of 6 plus the log of 2 is the log of 12. The log of x, sorry, let me off to the side. This right here is the log of 12. The log of 6 times the log of 2 is the log of 6 times the log of 2. But when you add logs, that's when you get to multiply the arguments. And by the way, 3 times the log of 2 times the log of 6. This is just some number. Right? You can plug it into your calculator. You're not going to, but this is just some number. It's just fancy with all those, LOGs in it. All right, divide both sides by the log of 6 plus the log of 2. That's going to isolate the log of x. So I'm going to divide both sides by the log of 6 plus the log of x. Sorry, the log of 2. Log of 6 plus log 2. I don't think I've ever said the word log so many times. Factored out the log of x, which left me with log of 6 plus log 2 of 2. And then I'm dividing both sides. Log of 6 plus log of 2 is just a number. I am going to write this as the log of 12, though. That is going to make things nicer. I'll do that in the next step. Base is 10. I wrote a 10 there. The base is 10. Well, let's change forms. If I want to solve for x, 10. I need more room. This is going to be big. 10 to the power of 3 times the log of 2 times the log of 6 over the log of 6 plus the log of 2, which is the log of 12. I'll rewrite that so you can see it, is x. And there is your answer. Let me rewrite that a little bit bigger. The base to this ends up being my exponent right here. So the answer is 10 to the 3 log of 2 times the log of 6 all over the log of 12. This is a number in your calculator. If I were doing this problem on my own, which I kind of am right now, actually, haha, I would get this number in my calculator and I would store it. And then I would plug in log base 2 of this number plus the log base 6 of this number is at 3. And it is indeed 3. I checked it.